divisibility criterion, I'm just going to prove the one for 13 here. It's kind of interesting why this works for all three numbers. It's the same criterion for all three numbers, and you'll see why fairly quickly. Now, notice what got me interested in this is that if you take this number, which is certainly a multiple of 13, this 116,506, notice that when you subtract these last three digits from the first three digits, you also get a number that is divisible by 13. Now, is that happenstance or a fluke? Well, it turns out it's not happenstance. There's a real good reason for it. Let's move along. Now, this is the standard way to write the Hindu-Arabic representation, decimal representation of an integer, where the a sub k's are all numbers between 0 and 9, integers between 0 and 9. Okay. Now, so we're going to conjecture that 13 divides if and only if 13 divides this difference. And if you see right here, that's exactly what we did right here. Like this piece right here would be the, as far as the notation we're using, whoops, sorry. That's supposed to be an arrow, ladies and gentlemen. Let me do better than that. Okay. Get back in business here. Okay, so this would be the same thing as a sub 2 juxtaposed with a sub 1. You know, just three digits, you know, next to each other. All right, a sub 1 and then a sub 0. All right, sorry y'all, I'm trying to use the trackpad. The screen moves when I use the mouse, so anyway, that's why I'm doing this. Okay, so again, the a sub 2, a sub 1, a sub 0 right here for 506, and the first three digits would be this part right here. Okay, now 3 is just happenstance here to keep the number small. It would be whatever's left, but you know, this happened to be a multi-digit number. You're interested in the last three digits and whatever's left over here. Okay, so let's move along. Now, we're conjecturing that this is true based on this scant numerical evidence. And why? Well, you can rewrite in this way, and this is the key aspect of the problem. See, you have to multiply the first group of digits by 1,000, and just to see that, I'm sure you probably do see it, but notice that the 116 right here, this 116 is actually 116. If you just separate it out in its decimal representation, that would be 116 times 10 to the third, right? Times 10 to the third. Okay, and you see that's where this three digits at the end comes in. You have to account for the location of 1116, and it's actually, this is the 10 to the third position, 10 to the fourth position, and the 10 to the fifth position. So you have to push it over three decimal positions, if you will, okay? So anyway, maybe that was a little bit too much explanation, but that's why n is equal to this, and that's crucial because you'll see that you can rewrite 1,000 as 1,001 minus 1, but 1,001 happens to be 7 times 11 times 13. 1,001 happens to be 7 times 11 times 13, okay? So the rest of this is just the expanding all of this out, all right? Expanding all this out, and we're supposing that 13 divides in, and we can clearly see that 13 divides this part right here. And so when you rearrange this equation, you could to get it in the form we're looking for, you can rewrite it like this and see that this object that we're interested in is indeed divisible by 13, but it's also divisible by all the others. All right, isn't that cool? All right, so in effect, we're done right now. Okay, we have shown that 13 divides this expression, provided that if n divides 13, or excuse me, if 13 divides n. I'm just writing it down. It's already been written somewhere else, but if 13 divides, if 13 divides n, it necessarily divides this, and it's an if and only if. I didn't really show it, but everything's reversible. Okay, now let's look at, I told you about 7, didn't I? So let's take a look at a problem. Let's do like a clear multiple of 7. I think 3521. 3521 So that's clearly divisible by 7, folks. You can see I just did that one. 7 times 503, right? 7 times 503 is equal to 3521. So 7 does divide 3521. But let's take a look at our little, our first digit here is actually, let me put if and only if, even though I didn't rigorously show it. Everything is reversible. So this is an if and only ifer. Yeah, all right. If and only if 7 divides 3 minus 521. I'm looking for a way to write faster. This just kills me. I'm having to use the trackpad because at least it's stable. But I'm looking for a quick way to write it. When I use the mouse, it's not really designed. It makes the screen move, So anyway, this is the price we're paying here. Now, so is this true though? Okay, is this true? So, oops, that should be a divides there. So indeed, 7 better divides 518. 7 divides 3 minus 521 is minus 518, right? That's okay. And we should be able to do this in our head, folks. Minus 518, what is... I'm trying to do this. What is it? It's got to be equal to 7 times something. That's equal to 7 times 74, isn't it? So 7.74. 7 times 70 is 490 and 20. Yeah. 7 times 74. Okay. So you see, it works for 7, and it also works for 11, as you just by the proof went. But anyway, folks, I went a little far afield, but I just think it's kind of neat how this works out nicely. But it's owing to the fact that 1001 has these divisors. You could make up a rule like this for the last 4 digits, the last five digits ad infinitum. But anyway, hopefully we've proven our conjecture. Hopefully you're convinced that it's true based on what I just did. Okay. All right. QED. Quite easily done, right? No, sort of. Okay, that's how you conclude a proof, right? Thank you for viewing.